All right, let's take a look at the practice test. So for the instructions, we're asked to find the exact value. And for the first problem, we have the cosine of 17 pi over 12. Now, a lot of people do not like working with fractions. So what I would do if you're struggling with that is to convert this over to degree mode. It's not necessary, but I think I'm going to do it here because a lot of people will find this really, really hard. So I'm just going to say that this is 17 pi over 12, and I'm going to multiply this by 180 degrees over pi. And then I'm just going to cancel this pi with this pi. 180 divided by 12 is 15, and 15 times 17 is going to be 255. So this would be equal to 255 degrees. So now that it's in degree mode, you can easily break this up. I would just come to my unit circle and think about what's available. Well, you could do 120 degrees plus 135 degrees. So if we come back, you could say that this is the cosine of 255 degrees is equal to the cosine of 135 degrees plus 120 degrees. Now, the reason we're doing this is so that we can get an exact value. If you just punched in cosine of 255 degrees with your calculator, you're going to get an approximation. Sometimes you want an exact value. So you can use your sum identity for cosine to get that using these two angles here. Now, if your teacher gives it to you in radians, you probably want to show your steps in radians. So I'm just going to convert this over and say this is the cosine of, for 135 degrees, that is going to be 3 pi over 4 in terms of radians. Then plus for 120 degrees, that's going to be 2 pi over 3 in terms of radians. So let me get rid of this. And again, that step is not necessary. It's only if you're really struggling, and it would only do it for a limited period of time. Just try to get good at working with these fractions. So let's come down here and let's use our sum identity for cosine. So with this, remember, if you have the cosine of, let's say, a plus b, it's the cosine of a times the cosine of b. Then the sign is always different. So if this is a plus, now this is going to be a minus. So then you're going to have the sine of A times the sine of B. So it's the cosine of the first angle times the cosine of the second angle, then a different sign. So if this is a plus, this is a minus. If this had been a minus, so we're using the difference identity for cosine, then this would be a plus. Then you'd have the sine of the first guy times the sine of the second guy. So a real easy pattern to memorize. So it's just the cosine of the first guy, so 3 pi over 4. Times the cosine of the second guy, so 2 pi over 3. And then because this is a plus, we want a minus. Then the sine of the first guy, so 3 pi over 4. And then times the sine of the second guy, which is 2 pi over 3. Okay, let me get rid of this. And these are values that you can get from the unit circle. If you want to come up and pause the video and just look at this point right here and this point right here, this is what you're going to need. Let me just copy this. So this is negative 1/2, comma, square root of 3 over 2. So we know that the x-coordinate is the cosine value and the y-coordinate is the sine value. Okay, so that's for 2 pi over 3. So let me just reference that this is from 2 pi over 3. And then from 3 pi over 4, you have an x value or a cosine value. That's the negative of the square root of 2 over 2. And then you have a y value or a sine value. That's going to be the square root of 2 over 2. So this is something you should definitely memorize as soon as possible. It's just going to greatly speed up your work. All right, let's paste this in here. I'll just throw it to the side for right now. So I'm going to say this equals the cosine of 3 pi over 4. Again, that's the x-coordinate from this guy. So that's the negative of the square root of 2 over 2. And then times the cosine of 2 pi over 3. That's the x-coordinate here. So that's going to be negative 1/2. And then I'm going to go minus. Let me get rid of this part right here. We don't need that anymore. We just need the y values. So the sine of 3 pi over 4, again, I need this y value here. So this is the square root of 2 over 2. And let me get rid of this. And the last one is the sine of 2 pi over 3. So that's going to be square root of 3 over 2. Let me put times there and just move this up. Okay, so now it's pretty simple, just some arithmetic. We're going to say this is negative times negative, which is positive. Square root of 2 times 1 is just square root of 2. And this is over 2 times 2, which is 4. And then minus the square root of 2 times square root of 3 is the square root of 6. And this is over 2 times 2, which is 4. A lot of people would just write this with a common denominator. So this would be the square root of 2 minus the square root of 6. You can't really do anything with that. Then over the common denominator of 4. So the exact value here for the cosine of 17 pi over 12 is going to be the square root of 2 minus the square root of 6 over 4. Okay, let's take a look at problem 2. So now we have the cosine of negative 105 degrees. Now you could work with the coterminal angle. If you took negative 105 degrees and you added 360 degrees, you would get 255 degrees. Now you might stop and say, didn't we just do that? The answer is yes. We just found that answer. But we're going to do this in a different way. So I'm not going to use the coterminal angle. I'm going to use my negative angle identity that comes with cosine. So the cosine of negative theta is equal to the cosine of theta. So I can say this is equal to the cosine of 105 degrees. And you can stop and again, punch this into your calculator and this into your calculator. You'll see you get the exact same value. Now, what you would do from here is just break this up. So I'm just going to do this in a different way. So let's go cosine of, let's go 150 degrees minus 45 degrees, just to change it up from what we just did. And 150 degrees minus 45 degrees is 105 degrees. So this is something we'll use the difference identity for cosine for. And again, we're expecting that same result, which is square root of 2 minus square root of 6 over that common denominator of 4. So let's see if we can get that. We're going to go cosine of the first guy, so of 150 degrees, times the cosine of the second guy, so 45 degrees. Remember, the sign is always different. So if this is a minus, this becomes a plus. Then you have the sine of the first guy, so 150 degrees, and then times the sine of the second guy, so 45 degrees. I think a lot of us know these values without going to the unit circle, but just in case you need it, we'll come up here. 150 degrees is going to be 5 pi over 6 in terms of radians. So we're looking at that point there. Let me get rid of these two previous points. And the other guy is 45 degrees, so that's going to be for this point right here. So again, let me write this as the negative of the square root of 3 over 2, and then 1/2. I'm just going to reference that came from this guy right here. So this is for the 150 degrees. And then for 45 degrees, let's say this is the square root of 2 over 2, and then the square root of 2 over 2. I think a lot of people know this one already. So let me get that there. Okay, so the first one is the cosine of 150 degrees. This is going to be the negative of the square root of 3 over 2. So the negative of the square root of 3 over 2, then times the cosine of 45 degrees is the square root of 2 over 2, then plus, for the sine of 150 degrees, that's going to be a half. So this is 1/2. And then the sine of 45 degrees is square root of 2 over 2. So times square root of 2 over 2. Let's make that a little bit better. So let's put equals there. So this right here would be the negative of the square root of 6, right? Square root of 3 times square root of 2 is square root of 6. And this is over 2 times 2 is 4. And then plus, you have 1 times square root of 2, which is square root of 2, over 2 times 2, which is 4. So it's the same thing, just in a different order. So you could say that this is the square root of 2 minus the square root of 6 over the common denominator of 4, like we just saw in the previous problem. All right, let's take a look at problem number 3 now. So here we have the cosine of 13 pi over 12. So again, if you're having trouble working with fractions and breaking it up, you can always convert this over to degrees. So let's just do that so that nobody's lost. So I'm going to take 13 pi over 12. I'm going to multiply this by 180 degrees over pi. And then the pi's are going to cancel. 180 divided by 12, that's going to be 15. And then 15 times 13, that's going to be 195. So this would be 195 degrees. If I had 150 degrees plus 45 degrees, well, that would get me to 195 degrees. So let me actually take everything now while I'm here so that we don't have to come back. And this is going to be 5 pi over 6. So let me just put 5 pi over 6. So that's 150 degrees in terms of radians. And I'm just going to notate that the x value here, the cosine value, so this is negative square root of 3 over 2. And the y value or the sine value is a half. So let me grab that. And then for pi over 4 or 45 degrees, let's write that here. I think everybody knows that's square root of 2 over 2 in each case, but let me write it out so that nobody is lost. And we're going to grab this, and let me come back and just paste this in here, throw it out of the way for right now. Let's get rid of this. I think maybe we don't have to write out our formula because we probably have memorized it by now. Let me slide down here a little bit. So this is the cosine of, again, I'm breaking this up into 5 pi over 6, which is 150 degrees, plus pi over 4, which is 45 degrees. Again, that would give me 195 degrees, or 13 pi over 12 in terms of radians. So this would be equal to, let me slide this over here, and I'll say the cosine of 5 pi over 6. And let me just take that value now so I can get rid of it. So this is negative square root of 3 over 2. And then times the cosine of pi over 4. So the cosine of pi over 4. So that's going to be this guy right here, which is the square root of 2 over 2. Let me get rid of this and this because we've used it. I'm just going to slide this down so I have room to work. And we'll go ahead and change colors here. So this is then going to be a minus because, again, this is a plus. So now I have the sine of 5 pi over 6. So that is going to be 1/2. So we know the sine of pi over 4 is going to be square root of 2 over 2. Let me get rid of this. I'm going to put the sine of pi over 4. Let's put equals, and let's put square root of 2 over 2. Pretty simple from here, just some basic arithmetic. So negative times positive is negative. Square root of 3 times square root of 2 is square root of 6. And this is over 2 times 2, which is 4. And then minus, we have 1 times square root of 2, which is the square root of 2, over 2 times 2, which is 4. So there's a lot of different ways that you could write this. I'm just going to keep it simple and say this is the negative of the square root of 6 minus the square root of 2 over 4. All right, for problem 4, we have the cosine of 285 degrees. So again, going to my unit circle, if I think about it, I could do 150 degrees, then plus 135 degrees. So let me write this out, 150 degrees. I'm going to grab these coordinates here. So the negative of the square root of 3 over 2, that's my cosine, and my sine is 1/2. And then for the other guy, which was 135 degrees, you know that has a 45-degree reference angle. So for the cosine value, it's the negative of the square root of 2 over 2, because again, we're negative in quadrant 2 for the cosine value, and the sine value is still positive, so that's just the square root of 2 over 2. So the negative of the square root of 2 over 2, and then this is the square root of 2 over 2. So let's grab this, and let me just paste this in here now, so we have it. So this equals, I'm going to say the cosine of 150 degrees plus 135 degrees. So this equals, I want you to just write this down. I'm going to get it out of the way. This is something that I've already memorized. And so hopefully you can memorize it very quickly because, like I keep saying, it's just going to greatly speed up your work on these problems. So I'm going to say this is the cosine of 150 degrees times the cosine of 135 degrees. Again, always change the sign. So this is a plus, so it becomes a minus. So now this is the sine of 150 degrees times the sine of 135 degrees. If you can't remember this from the unit circle, again, you can always think about things in terms of the reference angle. So 150 degrees has a 30-degree reference angle. So the cosine of 30 degrees is square root of 3 over 2, and we're in quadrant 2, so we know it's negative. So this is the negative of the square root of 3 over 2. Now, 135 degrees has a 45-degree reference angle. So if you wanted the cosine of 45 degrees, it's square root of 2 over 2. But again, this is negative because I'm in quadrant 2, so the negative of the square root of 2 over 2. Then minus. Now, sine in quadrant 2 is going to be positive. Right? So I can just think about the sine of 30 degrees, which is a half, and then the sine of 45 degrees, which is the square root of 2 over 2. So again, if you're having trouble with that unit circle, just go back to the concept of a reference angle. Sometimes it's a little bit easier. So let's come down here and put equals. So this is negative times negative, which is positive. Square root of 3 times square root of 2 is square root of 6 over 2 times 2, which is 4. And then minus 1 times square root of 2 is just the square root of 2 over 2 times 2, which is 4. So this would be the square root of 6 minus the square root of 2 over the common denominator of 4. All right, let's take a look at problem number 5 now. So here we see we have the cosine of 2 pi over 9 times the cosine of 4 pi over 9, then minus the sine of 2 pi over 9 times the sine of 4 pi over 9. So notice that this angle and this angle is the same. This angle and this angle is the same, and you have a minus here. So what does that tell me? Well, this is just basically us going in our normal formula for the cosine sum identity, but backwards. So in other words, normally you see cosine of, let's say, a plus b, and this is the cosine of a times the cosine of b, and then minus the sine of a times the sine of b. But because this is an equals here, I can go backwards, right? And I can put it in this form. So let's just do that real quick. We'll say that we have this being equal to the cosine of, take the first guy, so 2 pi over 9, and then again, this sign needs to be different, right? So this is a minus, it's going to be a plus. Then you're going to take the second guy, which is 4 pi over 9, right? So if you started with this, you know that you would expand it to this. So what I can do now is say this is equal to the cosine of, I have a common denominator of 9, so I can just go ahead and say, and this is a 4, it's just a poorly written 4. We can say that this is 2 pi plus 4 pi, which is going to be 6 pi. and this is over 9. Now I can reduce this fraction. 6 divided by 3 is 2, and 9 divided by 3 is 3. So this is going to be the cosine of 2 pi over 3. Now again, coming back to the unit circle, for 2 pi over 3, or 120 degrees, the cosine value is the x value from this point right here, so it's negative 1/2. So let's come back and just say this equals negative 1/2. Okay, let's take a look at problem 6. So here we have the cosine of 25 pi over 18 times the cosine of 5 pi over 9 plus the sine of 25 pi over 18 times the sine of 5 pi over 9. So again, this guy matches this guy matches this guy. Now you have a plus. So what you're going to do is say this equals, you're going to go cosine of the first angle, so 25 pi over 18. Because this is a plus, now you want a minus, and then you're going to take the second angle, so 5 pi over 9. So again, you're just going in reverse. So for this one, again, I have an 18 here and a 9 here. So let me just say this is times 2 over 2, so I can get a common denominator. So I'll say this is the cosine of 25 pi, and then minus 2 times 5 would be 10, so 10 pi, over the common denominator now would be 18. So we'll say this is equal to the cosine of 25 minus 10 is 15, so this would be 15 pi over 18. And we have a common factor of 3 between numerator and denominator. 15 divided by 3 is 5. 18 divided by 3 is 6. So this is the cosine of 5 pi over 6. So hopefully you know that's 150 degrees. And the cosine of 150 degrees, again, 30-degree reference angle. You're in quadrant 2. So it's going to be negative square root of 3 over 2. So this is the negative of the square root of 3 over 2. But again, you can always come back to your unit circle for 5 pi over 6. You're looking at that point there. Let me get rid of this one. And you want the x-coordinate, so negative square root of 3 over 2. All right, for the next few problems, we have new instructions. We want to find one value of theta. And coming down here for problem 7, we have the tangent of theta is equal to the cotangent of negative 40 degrees. So how can we solve this problem? Well, essentially what you're going to do is think about your cofunction identities. So remember that if you have the tangent of theta, this is equal to the cotangent of 90 degrees minus theta. Now, we used to say that theta had to be an acute angle back at the beginning of the course, but in this lesson that we just saw, we expanded the definition and theta can be anything as long as your function is defined, okay? So what we're going to do here is actually just replace the tangent of theta with this guy right here, the cotangent of 90 degrees minus theta. So that's all you have to do. So we're going to say this is the cotangent of 90 degrees minus theta, and this equals the cotangent of negative 40 degrees. Now, the reason this works is because you have cotangent over here and cotangent over here. So the only way that this can be equal is if this angle measure here is equal to this angle measure here. So what we'll do is say that 90 degrees minus theta is equal to negative 40 degrees. And what I'll actually do is add theta to both sides and add 40 degrees to both sides. And let's just go ahead and say that this would cancel and this would cancel. And I'm just going to flip it around. I'm going to say theta is equal to 90 degrees plus 40 degrees is 130 degrees. All right, so this would be my solution. Now, when we get to solving trigonometric equations, we'll talk about how to write the full solution, which would include all of the possible solutions. Here, this is just one of an infinite number. Okay, for problem 8, now we have the secant of theta is equal to the cosecant of 1/2 times theta plus pi over 9. So for this one, we're going to use the same strategy as the last one. Now this is in terms of radians, so let me say that secant and cosecant are cofunctions. So the secant of theta is equal to the cosecant of, instead of 90 degrees, I'll just say pi over 2, because we're working with radians, minus whatever theta is. And let me make the parentheses a little bit bigger there. Okay, so I'm going to replace this with this, so I can set the angle measures equal. So I'm going to say the cosecant of pi over 2 minus theta is equal to, and I keep making that too short, so is equal to the cosecant of this, let's just go ahead and say 1/2 times theta plus pi over 9. So again, this can only be true if this is equal to this. So we'll say pi over 2 minus theta is equal to 1/2 times theta plus pi over 9. Now, I don't like working with fractions, so I'm just going to multiply both sides by the LCD. You have a denominator of 2, 2, and 9, so the LCD would be 18. So let me actually show this. So 18 times this side, and then 18 times this side. So 18 times pi over 2, 18 divided by 2 would be 9, so this is 9 pi. And then minus 18 times theta is just 18 theta. And this equals 18 times a half is 9, so this is 9 theta. Then plus 18 divided by 9 is going to be 2. 2 times pi is 2 pi. So now we don't have any messy fractions, and so I'll just subtract 2 pi away from each side, and I'll add 18 theta to each side. And so this would cancel, and this would cancel. 9 pi minus 2 pi is going to give me 7 pi. And this equals 9 theta plus 18 theta is going to be 27 theta. Let me flip this around. I'm actually just going to write 27 theta is equal to 7 pi. I like what I'm solving for on the left. And I'll just drag this up here a little bit. I'm just going to divide both sides of the equation by 27. This cancels. And we're going to say that theta is equal to 7 pi over 27. So again, this is only one solution of an infinite number of solutions. So when we get to solving trigonometric equations, I'll show you how to get the full solution set. All right, for the next few problems, the instructions are going to change. Now we just want to verify each identity. And for problem 9, we have the cosine of theta minus 3 pi over 2 is equal to the negative of the sine of theta. So this one is really, really easy. I'm just going to flip this over here and put the negative of the sine of theta is equal to the cosine of this theta minus 3 pi over 2. This is just for formatting. I like what's changing to be on the right. If you want to do it a different way, that's up to you. So let's come down here, and I'm just going to put equals here. I'm going to use my difference identity for cosine. So this is cosine of theta. Let me slide this down. I don't think this is going to fit. And then times the cosine of 3 pi over 2. Then because this is a minus, I'm going to go plus. You want your sine of this theta here, and then times your sine of 3 pi over 2. So from here, it's pretty easy. Going back to the unit circle, so let me get rid of this. This is for 3 pi over 2. So remember, this is a 270-degree angle here. So the cosine value is your x value here, which is 0, and the sine value is the y value here, which is negative 1. So coming back, I'm going to take the cosine of 3 pi over 2, and I'm just going to plug in a 0. So this is cosine of theta times 0, which we know is 0. Then plus, for the sine of 3 pi over 2, I'm going to plug in a negative 1. So let's just put minus here. So minus, we'll say 1 times the sine of theta, like this. And of course, this is just going to go away. It's just 0. So you basically just have the negative of the sine of theta, which is what we had over there. So let me just put a check mark here to show we're done. Okay, for problem 10, this one's just as easy. So we have the secant of 3 pi over 2 minus x is equal to the negative of the cosecant of x. So let me flip this. So I'm going to put the negative of the cosecant of x is equal to, you have the secant of this 3 pi over 2 minus x. Now remember, if you're working with secant, it's the reciprocal of cosine. So what we can do right off the bat, let me move this all the way over here. I can just say this is 1 over the cosine of 3 pi over 2 minus x. So then let me put equals here. I'm just going to expand this. So let me put 1 over. We'll say this is the cosine of 3 pi over 2 times the cosine of x. And then this is a minus, so I want a plus. This is the sine of 3 pi over 2. Let me make this a little bit longer here. And then times the sine of x. Now, we know already that this guy right here is 0, right? So this is going to become 0. We know that this is negative 1, right? So this is going to become negative 1. So what you have here is 1 over basically the negative of sine of x. Now, we want the negative of cosecant of x, and we already have that. You could really break this up and say this is negative 1 times 1 over the sine of x. And 1 over the sine of x is the cosecant of x. So we can finish this up and say this is negative cosecant of x, which is what we wanted. All right, for the next few problems, the instructions tell us to find the cosine of s minus t. So here's problem 11. We're given the cosine of s is equal to negative 1/5. We're given that the sine of t is equal to 3/5. We're also told that s and t are both in quadrant 2. So let me come down here and say the cosine of s minus t is equal to the cosine of s and then times the cosine of t. And then because this is a minus, you want a plus. Now, whenever you put a plus next to a t, it's always confusing. So let me circle this so we know this is a plus. You have your sine of s times your sine of t. All right. So we are already given the cosine of s is -1/5 and the sine of t is 3/5. So the cosine of s, let me just say this is -1/5, and the sine of t is going to be 3/5. So how can we get the cosine of t and the sine of t? Well, some books will tell you to make a sketch, but you really don't need to do that. You can use your Pythagorean identity. I think it's a little bit quicker. So what you can do is say that cosine squared s plus sine squared s would be equal to 1. Now I know what the cosine of s is. It's -1/5, and I just want to square that. So let me get rid of this, and I'm going to put in -1/5, and I'm just going to square that. And let's come down. We'll come back up, and we'll say that -1/5 squared is going to be 1/25. And then we'll say plus sine squared s is equal to 1. Let's subtract 1/25 away from each side of our equation. This right here would cancel. Let me erase this so I can keep this in this frame here. I'm going to get rid of this and just move this up here. And then for 1, I would just write that as 25/25. So your sine squared s is equal to 25 minus 1 is 24, and this is over 25. Now we're going to use our square root property to find the sine of s, but remember it told us we were in quadrant 2. Sine is positive in quadrant 2. So you want the principal square root here. So you want to say the sine of s is equal to the principal square root of 24/25. And if you think about that, you can break it up. So let's say this is the square root. For 24, let's write that as 4 times 6 over the square root of 25. So for this, the square root of 4 is 2. The square root of 6, you really can't do anything with that. So this is 2 times square root of 6 over the square root of 25 is 5. So let me get rid of this, move this up here. So I'm just going to plug in for the sine of s, 2 times square root of 6 over 5. Okay, so this is multiplied, and then this is a plus sign here. Let me go ahead and circle this so nobody is confused. And let me slide this down just a little bit so the other guy fits in there. Okay, so this is going to be multiplied. So for the cosine of t, again, let's use sine squared t plus cosine squared t equals 1. I'm just going to write that a little bit differently. I'll say this is cosine squared t is equal to 1 minus sine squared t. And I'll plug in for the sine of t, it's 3/5. So let's write cosine squared t is equal to 1 minus, plug in a 3/5, and this is going to be squared. So 3/5 squared would be 9/25. And we can just speed this up a little bit. This would be 25/25. And we'll say that 25 minus 9 is 16, so this is 16/25. Now, we said that we were in quadrant 2. In quadrant 2, cosine is negative. So I'm going to say that the cosine of t is equal to the negative square root of 16/25, which would be equal to negative, the square root of 16 is 4, and then the square root of 25 is 5. So this right here, the cosine of t is -4/5. Let me get rid of this. I'm just going to put equals here and then just use these values. So -1/5 times -4/5, negative times negative is positive. So this is 4 over 5 times 5 is 25. Then plus, you have 2 times square root of 6 times 3. That's just going to be 6 times square root of 6 over 5 times 5 is 25. So you have a common denominator here. You can just say that this is 4 plus 6 times square root of 6 over 25. All right, let's take a look at problem 12 now. So we have the sine of s is equal to the square root of 5 over 7, and the sine of t is equal to the square root of 6 over 8. So s and t are in quadrant 1 now, so we know everything is positive. So coming down here again, we want the cosine of s minus t. So this is, again, the cosine of s times the cosine of t. And let me put the plus sign here and circle it so nobody's confused. This is a t and this is a plus sign. So now we would have the sine of s times the sine of t. Now we're given the sine of s and the sine of t. If we come back, the sine of s is the square root of 5 over 7. So this is the square root of 5 over 7. And the sine of t is the square root of 6 over 8. So this is the square root of 6 over 8. All right, let me put my plus sign here and circle it. And then what we want to do is think about the cosine of s and the cosine of t. Again, you can just use the Pythagorean identity. You could also make a sketch if you want. It's really up to you. So for the cosine of s, let's say that cosine squared s is equal to 1 minus sine squared s. And we know that the sine of s is square root of 5 over 7. So this is the square root of 5 over 7. So we're going to square that. So that would be 5 over 49. So this is 5 over 49. And I'm going to write this as 49 over 49. 49 minus 5, that's going to be 44. So this is 44 over 49. Now again, we're in quadrant 1, so everything's positive. So the cosine of s is the principal square root of 44 over 49, which is the square root of 44. Let's write that as 4 times 11 over the square root of 49. So square root of 4 is 2. So this is 2 times square root of 11 over square root of 49 is 7. So this right here for the cosine of s, this is 2 times square root of 11 over 7. Okay, so for cosine of t, we're going to use something very similar. We're going to say that the cosine squared t is equal to 1 minus sine squared t. Now the sine of t is square root of 6 over 8. So we want to plug in the square root of 6 over 8, and we want to square that. So this is 6 over 64. So 6 over 64. You can write this as 64 over 64. And 64 minus 6, that's going to be 58. So this is 58 over 64. Okay, so the cosine of t is equal to, let's say the principal square root, because again, we're in quadrant 1, of 58 over 64. So this equals, let me slide down here a little bit. We'll say the square root of 58 over the square root of 64. So the square root of 64 is 8. Now what about the square root of 58? Well, 58 is 29 times 2. 29 is a prime number, and also 2 is a prime number. So we really can't do anything else with this. This is just the square root of 58. So let me get rid of this, and let me drag this up here, and arrow to this, and put a multiplication symbol in there. And I'll just put equals here, and we'll use these values. So for this first guy here, you could cancel a factor of 2 between numerator and denominator, but I don't think you want to do that, because here you have 7 times 8, which is 56, and here you have 7 times 8, which is 56. So it's better to not do that so we have a common denominator, because we're going to be adding. So let's go ahead and say this is 2, let me slide this down here a little bit so it's a little bit better formatted, times square root of 11 times square root of 58. Now really you can't do anything with that, because 11 times 2 times 29, there's really nothing else you can do other than to say this is the square root of 11 times 58, which is 638, over 7 times 8 is 56. So then plus over here, square root of 5 times square root of 6, that's square root of 30, over 7 times 8 again is 56. Can you do anything here? No, you can't. This is going to be as simple as you can make this. You can write it with a common denominator and just say this is 2 times square root of 638 plus the square root of 30 over the common denominator of 56.